Okay, I can't actually time this right now because I'm using my phone to record this, and that's the only stopwatch that I have. So I want to show you how I set this up. I use the meter stick to find 1 meter height right here, and then I doubled that, and I found 2 meters height right here. And I've got 2 different balls I'm going to drop here. I've got a tennis ball and a golf ball, which are obviously not the same size. And I'm going to do this 5 times. All right, I'm going to try to be very careful to hold the ball at the correct height and drop it. And I found that it's easier to use my ear on the floor as opposed to trying to see the ball. Because a lot of times when I see the ball hit the ground, I'm anticipating and I'm hitting the clock, I'm stopping the watch too soon. So instead what I do is I line it up carefully and I will drop it, and when it hits the ground, I'll hit the stopwatch again. And the same is true here from 2 meters. Again, a little bit more difficult, I'm not that tall, but from here at a height of 2 meters, I'll start it when I drop it and I end it when it hits the ground, all right? So again, I'm gonna do that 5 times, and you can see I was already doing this before. I've got my data out here, and again with the golf ball and the tennis ball, 5 times each from both 1 meter and then 2 meters. All right, for this problem, we're going to be using a new kinematic equation, new to us that is, of d, distance, is equal to the initial velocity times time plus 1/2 the acceleration times time squared. And we're going to need to rework this quite a bit to get it to work for what we need to do, which is to solve for acceleration. And again, that's going to be the acceleration due to gravity. But there's one more thing you want to think about, and that is that because our initial velocity is 0, you're supposed to drop your item from your known height. So when you drop it, or before you drop it, it's not moving. Therefore, the initial velocity is 0. 0 times time, 0 times anything is going to be 0. So we can get rid of that term altogether. So let's do that first. And we're left with d is equal to 1/2 acceleration times time squared. And what I like to do to make this easier is to multiply both sides by 2, and that'll give me t2d, is equal to at squared. So I've gotten rid of that 1/2 there by multiplying both sides by 2. Now, again, I want to try to solve for acceleration of gravity. So to do that, I'm going to divide both sides by t squared, and I'm left with acceleration is equal to 2d over t squared. And that's the equation we're going to be using to solve this problem. All right, these two tables show the average time that it took the golf ball and tennis ball to travel 1 meter and then 2 meters respectively. And so the golf ball 1 meter was 0.50 seconds, and the tennis ball was 0.49 seconds. The 2 meter drop for the golf ball was 0.66 seconds, and the tennis ball's average time was 0.69 seconds. All right, and here you can see how I calculated the values. And again, we're looking for the acceleration due to gravity. And the golf ball at 1 meter is 8 meters per second squared. At 2 meters was 9.18 meters per second squared. There's a bit of a discrepancy there. But overall, 3 of the 4 values are very close, and they are not exact, which is probably due to flaws in my experiment, not flaws in gravity.